All right, good day, everyone. Now, I want to look at how to get conjugate acid and the base pair. How to get conjugate acid and conjugate base. Now, just take note of this. Our focus or study is what we call H plus, or hydrogen ion. In Bronsted-Lawrence theorem, it said H plus is a proton. Any substance that can donate this H plus is an acid. Any substance that can accept this lone pair is a base. So how do we get the conjugate acid and base now? What we do to get a conjugate acid, to get a conjugate acid, what you do, you add H plus to the compound. That's what you do. Not add H, but what? H plus. There's a difference between H and H plus. H is just an atom of hydrogen, but H plus is an ion, hydrogen ion. That's what we call it. So take note of that. H plus is hydrogen ion. Then to get a conjugate base, you remove H plus. You remove what? H plus from the compound. That's how we get conjugate acid. You add H plus. Conjugate base, you remove H plus from the compound. So let's look at a few examples now. Take note of that sign H plus. Now let's assume we want to look at the conjugate base. Let's look at conjugate bases now. Let's want to look at the conjugate base of H2 F plus. Let's want to look at the conjugate base of this compound. Now remember, I told you to look for conjugate base. What do? You remove H plus. So the conjugate base will be, now remove H plus from this place. If you remove H plus from here, what will be left to be, we have 2H already. You have removed one of the H and this plus sign here. Look at the plus here, it's already here. So the leftover now will be another H, will still be here because we have two of them. So we still have another H, then F and F. Can you see it? So this will be the conjugate base of this acid, because if we remove this H plus from this place, what will be left to be what? One H and just F. Take note of that. So this is the conjugate base of this acid. Now let's look at another one. Let's say we have HCl. We have HCl, and this HCl, if you check, what will be the conjugate base? If you check now, there is no, check very well, no sign here. It means it's neutral, it's zero. The sign there is zero. It's not either plus or minus, it's just neutral, zero. So what you do now, if you remove H plus from this place, the other one left, you will decrease it by -1. That's what I'm going to do. For example, if I remove H plus from here, because what is here is just heat, there's no plus. I'm the one adding the plus to it. So if I remove the H plus, the second one, I will have to decrease it by -1. For example, look at what I'm trying to say. If I remove H plus now, the one left will be Cl. I will decrease this one by -1. Why am I doing that? Because if I now add this -1 to this +1, it will give me 0. There will be nothing there again. That's why I'm doing that. -1 plus 1, 0. So there will be nothing. So if we do it backward, if you add this to this now, to be HCl, minus plus plus or minus 1 plus 1, that one becomes 0. So please take note of that. Now let's look at another one. Let's say we have the conjugate base of this compound, this lovely compound, which is H2SO4. H2SO4. So what will be the conjugate base of this? So remember what you do, just remove one H plus from here. So if you remove one H plus, what will be left? Only one H will be left. Then if you check this full compound, there's no sign here. There's no sign there. It's neutral. So if you are removing H plus, if you are removing H plus from here, if you remove H plus from that place, then only one H will be left. And the XO4 will still be there. Then what you now need to do to balance it so that at the end of the day, this plus sign will go, because there's no sign here. You have to balance this one with minus 1. Minus 1 plus 1, 0. The thing will cancel out. That's how to do it. Take note of that. Now let's look at more examples. All right, next is the conjugate base of H3O plus. What will be the conjugate base of this? What will be the conjugate base? Remember, we don't have conjugate base if we remove one hydrogen ion. So let's remove one H plus. So if you remove one H plus, how many H will be left? Just 2. We have H2. We have H2. Then O is here. O. Then what about this plus sign? Look at the plus here. It's already here. So if you add this to this now, H plus H2 will be H3. O plus plus. See, balanced. So don't go and add minus to this again. Because if you add minus, it will cancel out this plus, and it will not be equal to this side again. So there's no minus for the conjugate. So this will be the conjugate base of this acid. So let's look at this particular compound. The conjugate base of HSO4 minus. What is the conjugate base of this? HSO4 minus. So the conjugate base will be when we remove H plus in a very simple way. This one is already having minus. Anyone already having a sign in this place, any compound already having a sign here. If you just remove one hydrogen, we have only one hydrogen yourself. You just remove it, there's no hydrogen again. So what will be left to be SO4. The next thing you will do now, you will just remove one from this minus 1 that's already there. So minus 1 will give us minus 2. So that is just the short way to do that. Just decrease this one again by 1, minus another 1 again. Minus 1, minus 1, minus 2. That's one way to do it. Another way is to check. Another way is to check. For example, what we add to plus 1 and the answer will be minus 1, which is minus 2. That's another way. So the best way to just get it, if you remove one hydrogen ion from here, decrease this one by 1, or remove 1 from minus 1. Remove 1 from this minus 1, just remove 1. So you get the answer. So remove one hydrogen, already we have SO4. So this minus another one again will give us minus 2. So when you are removing hydrogen, you'll be subtracting 1 from this place. But if you discover that this one is having plus, if you remove 1 from plus 1, it will be neutral. So that's why in some cases like this one is neutral, because this one is already having plus. 1 minus 1, 0. That's why it's like that. So to check whether you are correct, just add this to this one. Minus 2 plus 1. What are you going to have? You still have this minus. Just minus 2 plus 1, it will be minus 1. So that's how it is done. So the power is not correct. Then you add this to this as well, you have HSO4. That is also correct. So the conjugate base of this now, if you remove this hydrogen, will be this SO4 minus. So just try and know how to get the sign. So let's look at more examples. Look at more examples. Try and see if we can do this one now. The conjugate base of H3PO4. What will be the conjugate base of this? Conjugate base. So that means conjugate base means we should remove one hydrogen. If we remove one hydrogen now, which is H plus, remember there's nothing here. So what are we going to do to the other side? How many hydrogen will be left here? 2. That's H2. Then others remain PO4. Then to cancel out this minus now so that there will be nothing here at the end of the day, you put minus. Minus and plus will cancel out. If you want to do it backward, if you add it together, minus and plus will cancel out, you still have H3PO4. That's what you're still going to have. Then let's look at others. Now let's say we are having HC, that's CH3 COOH. What is the conjugate base of this acid? So this is an organic acid, and this organic acid, this last hydrogen here is the one in question. Is the proton there, not this one, not that one. Take note of that, because CH3 is together, this CH3 is together, so take note of that. So if you want to do this now, if you want to remove hydrogen from this place now, we are going to remove this last one. Take note, not the one attached to this carbon. Take note. So the conjugate base now will be when we remove this. So we are going to remove H, but it will be plus. If we remove this H now, what will be left? We have CH3 COO. Then to count, because there's nothing in this compound, check, this compound don't have any power. So to cancel out this plus now, so if you want to do it backward, so I think we don't have any sign, you put minus here. Minus plus cancel, then add it backward, it will still be the same thing. You must ensure what you have here and what you have here are equal. That's what I'm trying to say. They must be equal to each other. So let's look at the next one. So we have HF. What will be the conjugate base of this? Conjugate base will be removing this. You're going to have, if you remove hydrogen ion, you're going to have F. And remember, this one don't have any sign. Check, there's no sign in the compound. So to remove this plus now, you put minus there. So minus plus cancel out. So let's look at this. H2CO3. What will be the conjugate base? Conjugate base will be, if you remove H plus, remember there's nothing, check the power, noted there. Check the power, nothing. So if I'm removing H plus now, the one left will be, I remove one hydrogen from this H2, only one will be left there. So CO3. Then to cancel out this, because this one don't have any sign, check, there's no sign there. So to cancel out that sign that is already in there, H plus, so you put minus. That's what you are going to do. So this is the conjugate base, conjugate base, conjugate base. So that is it. So after I remove this H plus, the one left will become the conjugate base. So let's look at some examples more. Now let's look at this particular question. Let's say we have H2X. What is the conjugate base of this? What will be the conjugate base of this? So just try and see if you can do this one yourself. Remember, what you have to do just to remove H plus. Then if you remove one H from this, what will be left? We have another one left, then X. To cancel out, because this, check this one, there's no power here. There's no power in this compound. It's neutral. So to neutralize this plus now, you put minus there. So that's all. There's nothing hard there actually. So let's say we have H2 PO4 minus. So the first thing, remove one hydrogen from here, which is H plus. Then you decrease this power by 1. If you remove the anyone that is already any compound that was having a power before, If you just remove one hydrogen, what you just do, remove one from the power. Just decrease it by one. Minus one give us what? -2. So we're going to have one hydrogen is already living here. So one will be left. Then PO4. Then remove one from -1. -1 again will be -2. So that's why I do good out. To check if you are correct, just add +1 -2. You have -1 left. So let's look at this. Let's say we have NH4 plus, what will be the conjugate? So this is the conjugate base, now. What will be the conjugate base of this? So conjugate base is when you remove one H. Remember, a plus is already here. So if you remove H plus now, so this plus and this plus will just tally. So the one left will become the conjugate base, which is N and H. One H is already leaving H. For how many H will be left? H3. So don't go and add minus again, because we already have plus in this place, and this plus we just something like balance that. So don't go and add minus to this place again. It will not be valid. So just leave it like that. So just leave it like this. So this will be the conjugate base of this acid. This is the conjugate base of this. I hope you know how the signs are alternating. Why some are not having signs, some are having signs. Because we just want to balance it so that the same, if you do it backward, it will be the same thing. Do it backward, the sign will be the same. Do it backward, the sign will be the same. So anyone, just note, anyone that don't have sign, H plus will carry plus, the other one will carry minus. Anyone that is already having minus sign, if you remove H plus, remove one from that minus. Just remove one from that minus. Anyone that is having plus, let's say plus, just +1. If you remove H plus, leave it like that, don't add anything. Take note of that, it's very, very important. If he's having +2, if you remove H plus, then the other one should be having +1. So that if you add plus plus, will give us +2. So that's how this thing is. So just take note. Let's look at a few more on this. Now let's look at the conjugate base of H2O. Conjugate base of which, if you check conjugate base, if you check very well, then it's covered that there's no sign in this place. Check no sign. So anyone we are going to do now, at the end of the day, should have no sign. So if you remove H plus, remove one H from this place. How many H will be left? Just one. One will be left there. Then O should either be here or here. But it's good if you put it here. That is better. But that's the one that is familiar to us. So if you check now, if you add these two together, you will have a plus sign. To cancel out that plus, because there's nothing here, what we have to do is just to, there's nothing here, check, there's nothing there. We have to cancel out this plus, just add minus to this. Minus and plus will cancel out, and it will remain as H2. If you do it backward, H plus H will be H2. O minus and plus will cancel out. So let's look at the last one under this stuff. HCO3 minus. What will be the conjugate base of this? So if you remove H plus, this H will go. One H, that is what we have only one H there already. Then the next thing, you decrease this one by 1. Just remove 1 from that. So -1 will give us what? -2. So we're going to have CO3 -2. That is all. As simple as that. To check if you are correct, just do +1 -2. Give you this -1 back. So simple as ABCD. Simple as ABCD. So let's look at conjugate acid now. Let's look at, we have been doing conjugate base. This is conjugate base of water. This is conjugate base of this acid. So let's look at the conjugate acid now of some compounds. Now the first thing we are going to do now is to check how to even get conjugate acid. It's just almost the same thing, but this one now is just reverse, like that reverse I was doing just now. I will say if you now add it together, check if you form the compound back. That's just what I'm doing. For example, now let's say you did something. Let's say you did something C, let's say H2O you did just now, and you got H plus is leaving, and the other one will be OH minus. So what I'm trying now is that if you are given something like this as conjugate base, to get the conjugate acid, just add the H plus. If you just add it, the answer you are going to get will just be the conjugate acid. So what we are doing here now is just adding for conjugate acid, we'll just be adding H plus. We'll not be removing H plus. We'll be adding H plus. That's what we'll be doing here. So the first compound I'm going to look at now, number 1, is the conjugate acid of NO2 minus. So what will be the conjugate acid of this? So what you just have to do, just put plus H plus. Just add H plus to it. That'll give us the conjugate acid. So plus and minus will just cancel out. You see that? Minus 1 plus 1, 0. That will just cancel out. Then NO2 plus H, that will be HNO2. So this will be the conjugate acid of this base. So we're already done with that. The next, conjugate acid of H2O. See, there's no sign with this. So if you add H plus now, if you add H plus, the conjugate acid will be H plus H2, that will be H3O, but there's plus here. So that plus will still remain because there's nothing here to cancel it. There's no sign there. So this plus will just still remain. So take note of that. It's very, very, very important. So we are going to do a lot of examples so that you will be able to get it. That's why I'm doing so much examples. Now the conjugate acid of B arrow minus. What you have to do, add H plus. So the conjugate acid will become, now let's check, plus and minus cancel out. Then B arrow plus H will be H B arrow. That will become, this is the conjugate acid of this, conjugate acid of water. So look at more examples. Now we have another example here. The conjugate acid of Cl minus. What do you have to do? Add H plus. The conjugate acid will become plus and minus cancel out. Then we have HCl. That's what we're going to have. Super CBCD. Then the conjugate acid of CO3, then raised power minus 2. Add H plus. Add H plus. Then the conjugate acid becomes plus 1 minus 2. Okay, H plus CO3. That will be HCO3. Then plus 1 minus 2. What do you have? Minus 1. Do you get that? This minus 2 here for this one now, plus this plus 1 that is there. Minus 2 plus 1 will give us what? Minus 1. Anytime you see plus, just take it as plus 1. Anytime you see minus, take it as minus 1. If it's 1, they will not write anything here. They just leave it like that. Take note of that. So that one is very, 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 very important. So let me quickly explain this one again so that you get it better. You just add H plus this. That will be HCO3. The next thing, you just add the signs. This plus minus 2. This one is plus 1 minus 2. That will give us minus 1. So take note of that. It's very, 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 very important. So the conjugate acid of HCO3 minus. For the conjugate acid of this one, what you have to do, add H plus to it. Then the conjugate acid becomes, look at it, H plus H, that will be H2. Then CO3. Then minus and plus. Since they are the same thing, we have minus 1 plus 1. We cancel out. There will be nothing here again. Take note too. So minus 1 plus 1, 0. To cancel out those. So there will be nothing there. So take note of that. It's very, very important. So let's look at another one. Conjugate acid of OH minus. What you have to do, add H plus. We are just adding H plus here. That's what we're just doing. So the conjugate acid will become this minus and this plus will just cancel out. See, they are opposite and in same magnitude. Minus 1 plus 1 is 0. Then H plus H will be H2. Then we'll have O. That will be water. So let's look at more. Alright, so get the conjugate acid of this compound. C2H5 NH2. Just add H plus. Then you'll be having C2H. Okay, look at, we have 2 H here. There's 1 H here. There's 1 H here. So if you want to add to this now, you add to this H that associates to this nitrogen, because that is the functional group there. So this H5 remains. Then we have NH. You add one to this hydrogen, because that is the functional group there. NH2 is the functional group. That is NH3. Then remember, this plus will still be here because there's no sign here to cancel out that plus. So this plus will still be there. Then plus. So that's what you are going to have. What about we now have CH3? CH3 is something like a methyl. C2H5 is ethyl. This one now, this one is a compound. It's the name of a compound, ethyl. It's the name of a compound, methyl. So that's why you cannot add to those ones. Then this other one is another name of a compound, which is a functional group. And if you want to do this now, CH3NH2 plus, just add this one now is this thing. You want to find the conjugate acid of this, just add H plus. So you're going to have the conjugate acid will becomes CH3. CH3 is a compound methyl, then NH. This H2 plus this H, that will be H3 plus. This will be the conjugate acid of that. So that's how you do those ones. Then let me look at this. Okay, let's look at ammonia. Let's say we have, look at ammonia. Look at ammonia. Let's say we have ammonia, NH3. So what is the conjugate acid of this? You need to just add H plus. Then you're going to have the conjugate acid, it becomes NH. H3 plus H, that is H4. Then remember, there's no sign here. There's no sign there. So this plus will still remain. There's nothing that can cancel it. That plus remains. So conjugate acid of F minus. The conjugate acid of this. Then you just add H plus to it. So you're going to have this minus and this plus will cancel out. So we have HF left, which is hydrogen fluoride. Then lastly, the last one I'm going to do for today is this one. The conjugate acid of PO4 minus 3. How do you find the conjugate acid of this? You just add H plus. So the conjugate acid will becomes H plus this PO4 will be HPO4. So we're going to have. Then let's work on this sign now. Plus minus 3. Just like minus 3 plus 1. What will be the answer to that? Minus 3 plus, this one is just plus 1. So minus 3 plus 1 will be minus 2. So that will be the sign. So this will be the conjugate acid of this PO4 raised to power minus 3. While this is the conjugate acid of this fluorine ion, which is F raised to power minus 1. This is the conjugate acid of this ammonia. So this ammonium ion. So please, thank you. God bless you all. See you guys in our next class. Don't forget to subscribe and like this video, then share to others to also help them. Thank you.